Hello everyone, welcome to the CAC 321 Operating System Lab. So in today's lab, we will be learning about the shell scripting. So if you remember from the previous lab, we have covered the basic shell commands. So in this lab, we will be learning about the shell scripting. Shell scripting is a very powerful tool to automate some tasks in the operating system. Now if you remember from the previous lab that we used the command line interface, the terminal, to interact with the operating system. However, each of the for each task we had to write a specific command. Now say for example we have a sequence of commands. Now it can be like creating a directory and then moving files to that directory. So there are two different commands, and for that you have to write two different commands in the terminal. And then if you want to do this like every single day, then you have to write the same commands every single day. Now there are just two commands, right? But it can be like there can be multiple commands, or there can be some conditional commands. So if that happens, then you want to do this. If this happens, then you want to do this. So for that kind of scenario, we use the shell scripting. Now for our shell scripting, we will be using something called bash, the born again shell. The born again shell is just a scripting language for our shell. Okay, so basically all of the commands that we had learned earlier in our basic Linux command lab, we'll be using those commands, and we'll be learning some new syntaxes to write the script and then use those commands to our benefit. Okay, so let's see an example. Now in the Java or other operating system, we used an IDE, right? So in the beginning we used like the Dr. Java, and then we shifted to Eclipse or NetBeans or IntelliJ, whatever. So for the bash, what we're going to be using is just a simple text editor. Okay, now you can use an IDE, say for example the Visual Studio Code. You will find the plugin for bash, so it will give you all those features like the autocomplete or the error detection and everything. But in this lab, we have very small tasks. So for those tasks, you really don't need an IDE. You can just use any text editor. A simple plain text editor should be enough. I'm going to show you multiple ways to write the shell scripting in a text editor. Okay, so the first one that I'm going to show you is using the text editor of the graphical user interface or the desktop environment. Now to run this, you can go to your all application and then search for the text editor, so this one, or you can just simply turn on your terminal and then type gedit. So hitting enter will open your text editor of the graphical user interface. So each graphical user interface should come with a text editor, something like this, or a desktop environment should come with a text editor, something like this. Okay, now you can write your code over here. So let us write our first code. So now as I've said earlier, that we can use all the commands that we have learned in our previous lab in this scripting. Okay, so let's just make it create a new directory called new1. So mkdir new1. So this was our one of the commands from our previous lab, which would create a directory named new1. Okay, so for example, for the first task, let's keep it simple. For this one, just leave it like this. Okay, now all you have to do is just save it. So we click save, and it will give us a prompt where we want to save it, and say I want to save it on my desktop. So and then I have to name it. So let's name it just so let's just name it test dot, and the extension is sh for the bash. Okay, now for Java it was .java, for C it was C, for Python it was py, and for the shell it is .sh. Now we can just click save, and it should save the file. So as you can see over here, we have created the test.sh file, and we can also open it and then see that we have the command written over here. Now let's try to execute the file. Okay, so at first we have to locate the file. So we know that we have created the file in our desktop directory, and whenever we launch a terminal, it will open in the user's home directory. So we have to change the directory to the desktop. So let's write cd dot desktop. So cd space desktop, and then it just navigated us to the desktop directory. So now we are within the desktop, and if we write ls, and we can see that this test.sh file lives here. So now here, to execute any file, we have to write /. To execute any file, it can be a Python file or anything. So whenever you're trying to execute any file in the terminal, all you have to do is just write dot and slash and the name of the file. So we're trying to execute test.sh file, this file. So /test.sh. Now let's see what happens if I hit enter. So as you can see, it says permission denied. So if you remember from our previous lab that we had a specific permission that was allocated for the execution of a file, right? So let's see what is the status of the permission of our file. So we have to write ls space -l and hitting it. So I am the user because I have created the file, and as I can see over here that I have the read access, the write access, but I do not have the execution access. That's why I cannot execute the file. So it's giving me this permission denied error. So let me give the execution permission first. So for this we have to write chmod, and then so I'm the user, u plus the x for the execution permission, and then space name of the file, which is test.sh. So if I hit enter and then let's check, okay, now I have the execution permission. So let's try to execute the code. So let's do this. As you can see that our code has been successfully executed, and then it has created a new directory called new1. So our script is running perfectly. So let's try to do something more. Okay, so we have created a new directory, fine. So if you remember that we have created this test.sh file using a graphical user interface, using a text editor, right? Say for example you do not have a graphical user interface in your operating system, then how do you create a file? Well, we know from the previous lab that we can use the cat command to create a file, but it's not very intuitive to use the cat command. Okay, now for that we have something called the command line text editors. Okay, so some text editor that are built into the command line. So examples are something like Nano and Vim. Vim is very advanced, so if you learn Vim, it's fine, you can do a lot with the Vim, but Nano is very simple and easy to use. So I'm going to show you how to use the Nano to create a shell scripting file in the terminal. So for this we have to write for this we have to write nano, then space the name of the file. Now so this time I want to make a script that prints something. Okay, so let's create something that prints hello world, hello world.sh. So nano space then the name of the file that I want to create. So I want to name the file hello world.sh, that's why I've written hello world.sh. So if I hit enter, then it will take me to the command line based text editor. Okay, so it works just like a text editor but within the command line. So now I want the script to print hello world. So how do we print it? So in Java we have like system.out.println. In Python we have just print. So for bash we have something called echo. So when you say echo space then a string, it will just print a string. So of course we start with the good old fashioned hello world. So let's just print hello world. So echo then hello world. So it should print hello world. So let's save it. Now for save we have to use Control and X. Save modified buffer, yes. So you press Y and then hit enter. So as you can see we have another file called this hello world.sh, and now we want to execute the file. Okay, again, if I want to directly execute it, hello world. Now if I want to directly execute it, it will give me the exact same error, permission denied. So what can we do about this? So of course we can just use the chmod to modify our permission and then add the execution permission and then execute it. But there's another way. So to do this, we use bash space and then we write the name of the file, which is hello world.sh, and then if I hit enter, as you can see, the file is executed and hello world is printed despite having no permission to execute. Now how is that even working? So if I print the permissions, so now for our test script, we did not have execution permission. That's why we added execution permission, and then we use this // to execute the command. Now what we're doing here is we are abusing something. Okay, now what is that? So when we created this hello world, by default we were given read and write access, but no execution access. So what we're essentially doing is we're asking the bash to execute this file. Now whenever in the Linux operating system, whenever you tell an application to open a file, the OS will check if you have the read access or not. So when we're doing this bash, then space the name of the file. So the OS is checking if I have this, if I have the permission to read this file, and yes, I have the permission to read this file. So that's why it's allowing bash to execute this file for me. So I'm basically asking bash to execute the file. So in this way, we were directly executing the file. For that, we need the execution permission, this X. But if we don't want to execute a bash file directly, we can simply ask the bash to execute the file for us. So I'm asking the bash to execute this file, and then since I have the read access, it is executing the file for me. So this will come in very handy, because now that you don't have to like modify the command each and every time you create a new .sh file, and then you have to just add this execution command over and over and over again. You don't have to do it now. All you have to do is just use this. So bash space then the name of your file, and then it will just execute it for you. Okay, so it will come in very handy. That's why I'm showing you that you can basically abuse this read permission to execute a shell script. Okay, one thing you should always do is specify which shell you're using to write your script. So in this lab we'll be using the bash, so we have to specify that we are using the bash script. So how do we do that? We have to write simply this line, okay, /bin/bash. Now you might be wondering, okay, why do we need it now? The code just worked fine without this line, so why are we writing it now? So the reason is your operating system may have multiple shells. Now I have given you some of the examples in the previous lab that there can be shells like corn shell or Z shell. Bash is just like another shell, so it's a born again shell. So the problem is each and every shell uses this exact same extension .sh. So there's no way for the operating system to know which shell is used to write the script. That's why we should always specify which shell we are using. So what we're essentially doing is we are asking the operating system to look for the shell over here. So / is the root, so then the bin directory, and within that bin directory there is a bash directory. Okay, so always remember to write this line on top of your script. Now I'm going to show you another way of writing the shell commands. Now, you may not have access to a Linux-based operating system, but you need to do the shell scripting for your assignment, right? So how do you do that? Now, luckily, we have a lot of online-based shell compilers available that we can use to do our task. Now, I'm going to show you a specific online compiler, but you can use any whatever you are comfortable with, you can use it. Okay, so if you search for like the online bash compiler, and then you will find a lot of result. You can use any of them, but I'm going to show you the one that I find it very easy to use, which is this one. So it's REPL.it. So clicking it will take you to the website where you can write your code and execute it. Okay, so if you don't have access to a Linux-based operating system, you can simply use this website to write and execute your shell scripts. And the good thing is it has dark theme. So as you can see, there is like already a sample command that is written over here. So you can just simply run it, and as you can see, it's printing hello world. So echo hello. So we should always specify which shell we're using, so it is always better. So if I run it, as you can see, it's printing hello world. Okay, the right side is your terminal, so you can execute all the commands over here. So say for example you want to create a directory, simply you say mkdir and the name of the directory. So it can be like new one. If I hit enter, as you can see that there is a new directory that has been created, new one. So we can write like ls, and see it's showing main.sh and new one. So main.sh and new one. Now if we want to execute this main.sh, we can always do this bash space then main.sh, hit enter, and it's executing this main.sh script and printing the hello world. So this right panel is basically your terminal, and the middle one is your text editor, and the left part is your file manager. You can see all of your files over here, and the text editor is in the middle, and on the right is the terminal. Now let's learn something more advanced. Okay, so first of all, we are going to see how to declare variables. So to declare variable in bash, all you have to do is write the name of the variable and then equal and then the value of the variable, say 5, and then say b equal my name. Okay, now you might be wondering that there is no type declared before the variable. So you might be wondering, okay, so is it a dynamically typed language or something like that? The answer is no. So basically it treats everything as a string. So I have written 5 over here, but it doesn't really matter, it's a string. My name is already a string. So whatever you do, whatever you declare, it's always going to be a string. So A, B, C, D, you can name it anything you want. The variables, whatever you put inside the variable will be treated as a string. Okay, so here 5 is also a string, and then this my name is definitely a string. So okay, so everything is a string, fine. Now let's see how to access this variable. So if I want to print b, so echo, and then if I just say b, now if I run it, okay, it's just printing b, but I want to print the value of the b. So now whenever we want to print value of a variable or a value of something, all you have to do is just indicate it with a $sign. So otherwise the script has no way to understand, like if we are trying to print the value of b or we are just trying to print b. So that's why we use this $sign before the variable to print the value. So now if I print here, so as you can see $sign b, so it's printing the value of b. Okay, let me increase the size large. There you go. Okay, so $sign b, that means it's basically printing the value of b. Only b is just printing this b. So just b. So you can see b and a. So if you run it, it's just printing b and a. Okay, now if you want to print this value of b and then value of a, we have to write it like this. So as you can see, my name and then 5. Okay, now let's learn how to take inputs. Now let's get rid of this. So we want to print the input that user have given. Okay, so echo, and let's just prompt the user to enter his name. So enter a name and then colon. Okay, so this is basically like system.out.println and enter a name. And then what was our second step? We used a scanner to scan the variable, or in Python we used input to take the input from the user and then put it in a variable. So for this we have something called read, and then read space, and whatever you name the variable will be used to store the input from the user. So say I want to use this name. So name is the variable of the name and read is the keyword. So all you have to use is just read and then a variable name, and the input will be stored in that variable name. Okay, now we have to print it. So echo, so let's say the name of the user is name. Now we need to access the value of the name, so $sign name. Okay, let's see what happens if I run. So enter a name, so let's call it Abul, and as you can see the name of the user, okay, there's a typo, so the name of the user is Abul. So it's working. So you use this read to take input from the user. Okay, now I'm going to show you how to do the arithmetic calculations in bash. So for that, let's declare some variables, say a is equals to 4 and b is equals to 2. Okay, now as I have stated earlier that all of the variables are basically string, so everything is a string. So if you try to write something like this, so echo, you want to add the value, so value of a and then plus value of b. So let's see what happens if I run it. So it's just printing 4 plus 2. Basically it's everything, because everything is a string, so it's 4 and then plus is also a string and 2. So now how do we then use the variables to calculate some arithmetic expressions? So say we have this, so even if we try to do something like this, so we declare c and then we try to add those two and then print c. So let's see what happens. Yeah, the same output. Okay, now to do arithmetic operations, all we have to do, there are two ways basically. So one is using the expr, which I definitely do not like. Now I'm going to show you the much easier way to do arithmetic operations. Okay, so all you have to do is just add two brackets. So whenever there are two brackets, so it indicates that whatever there is inside is not a string, it's basically a arithmetic operation, sorry, an arithmetic expression. Okay, so this is an arithmetic expression, so you can also place space inside it, it doesn't matter. So what we're doing here is we are $a, which means we are taking the value of a and then adding it with $b, that is the value of b. So now this will return a value, so we will have to access the value of the whole thing. That's why we need to add another $sign at the front. So now if we try to run it, so as you can see, this time it's printing 6. So whenever we need to do arithmetic operations, we just use this double bracket. So inside a double bracket we can write any arithmetic operation, arithmetic expression that we want. So it can be like minus, so you can divide, or you can multiply. So see, 4 times 2 is 8. You can even square just by using double asterisk, just like Python. So see, 2 to the power 4 to the power 2 is 16. Okay, so this is how we do arithmetic operations in Bash. Now we're going to see how to use if-else condition in Bash. Okay, now for this we're going to be using an example, and so basically we're going to compare two we're going to first input two numbers from the user, and we're going to compare if they are bigger or smaller or equal. Okay, so let's see how to do this. So first let's prompt for the numbers, enter a number. So let's store it in a, and then another prompt, just enter another number, and let's store it in b. Okay, now we have a and b from the user. Now we are going to compare. So first let's see if a is greater than b or not. So if, now the way you write if condition is first you write if, then space, third bracket, then again space, and then your condition. So now I'm trying to see if a is greater than b or not. Now usually we could write something like this, so if a is greater than b. However, we cannot use this kind of operator in Bash. So we have a specific set of operators that you have to use for the condition. So now that I'm trying to compare a and b and see that if a is greater than b, so I have to use minus or hyphen GT, which stands for greater than. So I'm checking if a is greater than b. Now remember, one more thing we have to keep in mind, that we are actually comparing the values of a and b. So to access the value we have to write a $sign, right? A $a is greater than $b. That means the value of a is greater than value of b, and this will return a boolean, and then we can check this if condition. So then you write this semicolon, and on the next line you write then, and then you have to write the statements. So say I want to print echo that $a is greater than $b. Okay, so we're just checking that if a is greater than b, if it is true, then it will print the value of a is greater than the value of b. Oh, all right, so then now we have to check if a is less than b or not. So we have to use else if. Now for else if we use something called elif. elif, then again we have to write our condition like this. Now remember, there is you have to use this spacing. Okay, this is required. So if, then space, then third bracket, then space, then your expression, so operator, then operand, then operator, then operand, then space, and third bracket close. So these spaces are very important. So similarly, for else if, which is elif, we have to use the spacing as well. So space, then third bracket, then again space. So we have to use space on both sides, and then in the middle we have to write the condition. So now we're trying to check if the value of a is less than or not. So for less than, it is lt, less than $sign b. Okay, again semicolon, and on the next line say then, and we have to write our condition, sorry, our statement. So which is it's the same thing. So I'm just going to copy it. So let's copy it and paste it. So it is now less. So if the value of a is less than the value of b, it will print the value of a is less than the value of b. Okay. So finally, if a is not greater than b or not less than b, so it has to be, both has to be equal. So both have to be equal, right? So else, then, so when you're writing else, you don't have to use then. So just write your statement. So now I will be printing $sign a, which is value of a, and $sign b, value of b, are equal. Okay, so the value of a and value of b are equal. Okay, so again let's repeat. So if condition, we have to write it like this. So if space, then third bracket start, then space, then our condition, then again space, third bracket, then semicolon. Elif similar, and for else we don't have to use the then. Okay, just like this. And now if you remember, in Java we use the scopes, or the second brackets, to identify where the if is starting and where the if is ending. Now, and in Python we use the indentation to identify the starting and the ending of an if condition. And here we use something like reversing the keyword. So if it is if, then we have to reverse it, which is fi. So this will indicate the end of this if statement. Okay, so the statement starting over here, and so there's a phi, which is the reverse of this if, that is indicating that it is ending over here. Okay, so let's run it. So enter a number, say first number is 5 and another number is 6, and see 5 is less than 6. Yeah, that's right. So now let's see if something is greater. So the first number is 5 and the next number is 2. So yes, 5 is greater than 2. Nice. So let's try the equal. So say both are 5. Okay, 5 and 5 are equal. See? So our code is working. So this is how you write the if conditions. We can also use these conditional statements to check some OS level things. So let's see an example. Okay, let's get rid of this code. Okay, enter okay, let's make it enter a name. So what we are trying to do here is the user will enter a name, and then we the code will basically try to identify if there is if there in file exists with that name, and if there is a file, and then what type of file it is. Is it a directory or a normal file or something else? So let's try to do this. So okay, echo enter a name. So user will enter a name, and we will store it in, say, a file name. Okay, so we are going to store it in file name, Nice. So for that, let's create some directories. So let's make it, so ASD is a directory, and then we're going to create a file with DEF. Okay, so we have a directory, so we have a yes, we have a directory named ASD and a file named DEF. So user will enter a file name, and then we first we will try to see if there is any file or directory with that name, and then if there is a file or directory, then we'll try to identify if it is a directory or a regular file. So let's see how to do this. We have a special set of operators for this kind of operations, so we are going to use those operators in this case. So we are going to use the if else condition to check the file and the directory name. So first I'm going to check if there is any directory name with that file name. So to check the directory, I have to use -d or -d, then space the file name. Okay, so the file name. Okay, so again we're trying to access the value of file name, so we have to use $sign before that. Okay, then the semicolon, let's not forget about this, and then we have to write then and our statement. So I'm going to print echo it is a directory. Nice. So next we are going to check so next we are going to check if it is a file or not. So for file we have to use -f or -f, then $sign, file name, semicolon, then and our statement. So echo it is a file. All right, and now the else. So if it's not a file or directory, let's just print not a file or directory. Okay, now to end if, we have to use fee. All right, so let's try it out. Okay, enter a name. So let's use ASD first, and yes, it is a directory. Let's run it again. For the DEF, let's hit enter. Yes, it's a file. And let's try something random. Yeah, not a file or directory. So it's working. Nice. Now let's see how to use the switch case in bash. So for this we are going to use another example. So first let's change it to just name. So user will enter a name, and based on the input we are going to print something. Okay, so we're going to use the switch case. So for that we have to write case, then space the variable, which is name. Again we're accessing the value of the variable, that's why $sign, and then we have to use in, and from the next line we have to use the cases. Okay, so the first case, let's say if user enters Abul, so the case, then we have to use this parenthesis, and then we have to start our statement. So echo say the name is Abul. Okay, so if the input is Abul, then it will print the name is Abul, and then for this we have to use double semicolons. Okay, and next, say if the user says Kashem, then we are going to echo the name is Kashem. Again, double semicolons, and for default we have to use the asterisk. Okay, the asterisk, and then again parenthesis, and we have to use say we're going to print like something else, we don't know. Okay, again similar to if, we ended if with the reverse of if, which was phi, and for this case we are also going to reverse this keyword. So for case, the reverse will be something like ESAC, so ESAC. Okay, so this is how we write the switch cases. So let's run it. Okay, enter a name. So let's try Abul. Okay, so for this case it's printing the name is Abul, and let's try Kashem, and for this it's printing Kashem. Nice. And for everything else it should go to the default case and it's printing something else. Nice. Now you might be wondering, okay, why there are two semicolons now? Okay, so the reason is this two semicolon indicates the last statement of a switch case. So now that we have like a single statement, it doesn't really matter. So it is the last statement. So for example, let's say we have another statement. So let's say Abul is the name. So we have like another statement here. So now to indicate the end of this case, we have to use double semicolon for the last statement. So if we can have like a number of statements within a single case, and each of the statement will end with a single semicolon, except for the last one. The last statement for a case will end with double semicolon. Okay, now if we run it, so say Abul, so see, it's now executing multiple statements within a single case. So that's the basically reason why we are using double semicolons. So this is how the bash interpreter understands that, okay, this is the end of this case, and then next case is starting from here. Okay, so that's the reason for double semicolons. Now we are going to see how to use the for loop in bash. So first we are going to see how to use the traditional for loop. So for this we have to write for, then we have to use double bracket or double parenthesis, and then we have to write something similar to Java. So say I is equal to 0, then I is less than 10, and then I plus plus. Okay, you can use space if you want. Okay, so there and over there. Okay, now so this is how you write the traditional for loop, and then you have to use something called do. Okay, this do keyword indicates the beginning of for loop, and then say we are just going to echo this value of I, so $i, and then just end it. Now to end the for loop we have to write done. So do indicates the begin of the for loop and done indicates the end of the for loop, and between the do and done we are going to write our statements. Okay, now let's run it to see what happens. Okay, so our code is running perfectly, starting from 0, and since it's less than 10, so it's printing up to 9. Okay, so this is how you write the traditional for loops. Now we're going to see how to write the for each loop or enhanced for loop in bash, like we write the for loops in Python. Okay, now for that first we need to see how to declare list. So to declare a list, so you name your list. So let's say it's called my list, and equal, and use the parenthesis, and within that parenthesis you have to write your elements and separate it using a space, so A, B, C, D. Okay, so this is our list called my list. Now we are going to iterate through the list using a for each loop. So again for, then we need a variable, so it's I, then we use in, and we're iterating this my list, so my list. Now we have to do something crazy to iterate through this list. Okay, so just bear with me. So first we have to use the $, then the second bracket to enclose it, and on the right side of your list identifier you have to use the third bracket, and then you can use either @ or asterisk. So you have to write it something like this. Okay, so you have to write in this way. So and then semicolon. So again similar do, and now we are going to echo this value of I, and then done. So basically we're iterating through this my list, and for each value we are printing the value of I. Okay, let's run it and see we are printing this list. Now I know it looks it looks a bit crazy, but this is how you iterate through list in bash. Okay, now we're going to see how to use the while loop. So let's first declare a variable, say I is equals to 0, and we're trying to run the while loop. So say while, then you have to use space and then third bracket and then again space, and within that third bracket you write your condition, so which is, say, I want this to run if while I is less than 10. Okay, so I is less than 10. Now we cannot write it like this, so again we have to use those operators that we have used in our if else condition. If you remember, for the less than we have to use minus lt or hyphen lt. So while I is less than 10, so again the value of I should be less than 10, so let's use a dollar sign. So the value of I is less than 10, while then it will do something. Okay, so to start the while loop I have to use again do and then write the statement. So let's just print it. I'm just going to print the value of I. Okay, so now I have to increment this value, so let's increment it. So the value of I will be so now in a traditional programming language we could simply write something like this, right? But again, if you remember, for mathematical operation or arithmetic operation, I have to use this double bracket and then dollar sign. Again, we're adding 1 with the value of I, so dollar sign. Okay. Let's give it some space so it is easier to understand. Okay, so basically the value of I will be updated by incrementing it, or just adding a 1 with it. Okay, and then done. All right, let's run it. Okay, so it's working fine. So it's 0 to 9. This is how you write the while loop. Now you might be wondering, okay, so for if else and for those switch cases, we started with the keyword and ended with the reverse of that keyword, but now for the for loop and for the while loop we are using do and done. Why is that? Okay, now I don't know why is that, but the easier way to remember is whenever we're using any loop, so it can be for loop, while loop, or there's another loop in the PDF you will find which is called the until loop. So whenever we're dealing with loops, we start it with do and end it with done. Okay, and whenever we're dealing with the conditions, the if else condition, the switch case condition, we start it with the keyword and end it with the reverse of that keyword. So this is how you remember when to use this do done and when to use the reverse. Now we're going to see something called the command line arguments. So how to use the command line arguments in bash. So command line arguments are useful to take input from the user instead of prompting the user after executing the shell. Okay, so whatever we were doing up until now was, first the user executed a script and then we were prompting the user for a specific input. Now we can directly take input while the user was trying to execute the script. Okay, now how to do that? Say for example, let's clear it first. So as you know, to execute a script from the terminal, the user either have to // and then execute it, or use the bash to execute a command. So let's say bash, and then we are trying to execute this main.sh file, and then with the space user can pass some command line arguments before executing this this script. So it will help us to reduce the number of statements and the number of steps to execute a shell script. So before we were executing first and then asking the user for, say, an input, a number or a name or something like this, and then we executed the other statements. So instead we can just directly pass some arguments using the command line arguments. Okay, so the user will have to just use a space and then pass anything, and user can pass any number of inputs using the command line arguments. So say user is passing A and then with another space B and then C and then D. So here, as you can see, the user have passed 4 inputs. Okay, now if I run it, well, it's doing nothing because I haven't written anything, but it's not giving us any error. That means the inputs are basically accepted by the bash interpreter. Now how to access these inputs? So to access the inputs, we have to use the $sign and the number. So we have to use the corresponding number for the corresponding input. Now this is our first input, second, this is third, this is fourth. So if we want to access the first input, all you have to do is just indicate it with a $sign 1, which will give us access to the first input. So let's run it. Okay, we have to use the command line argument, sorry, the command line terminal to execute this script, because we are using the command line arguments. Okay, so run it. So see, it's printing A because the first value is A. Now if I use 2, now let's see, let's run it again. The second is because the second value is B, right? So similarly you can use 3, 4, 5 to access the number of to access any input that has been given using the command line argument. Okay, now so let's see what is printed if we use this 0. Let's run the same command. So basically 0 indicates this very first command, which is the name of the file. So it's just printing the name of the file. Okay, now if we want to know that how many inputs the user have given, then we have to use this then we have to use the hash sign. So $sign hash, this will give us the number of inputs. So if we run it again, so see, the user have given 4 inputs, that's why it's printing 4. If there are 5 inputs, and as you can see, it's printing 5. So this hash will give us the number of inputs or the number of arguments. So to access the value, we have to use $sign. And to access all of the arguments as a list, we have to use the asterisk sign. Okay. Now if I try to print it, let's see what happens. As you can see, we are accessing all of the commands just using the asterisk sign. You can also use the for loop to iterate through this list using the for each loop. You can try it yourself, okay, and see how it works. Now for our last topic, we will see how to write functions in bash. For this, you can either use the function keyword and then name your function. So let's create a function that prints hello world. Okay, and then after naming your function, you have to use this parenthesis and then use the second bracket, and then inside this scope you have to write your statements for these functions. So let's just say it's going to print hello world. Hello. Okay, now to execute this function, all you have to do is just call the function by its name and it should execute it. So let's run it. So as you can see, we are executing this function from here, and inside that function is just printing hello world. So we are seeing this hello world text here. You can also remove this function, you don't really need it. This should also work. See, so just naming the function and then using the parenthesis will work. Now if you remember, in Java, whatever you declare inside a scope was accessible within that scope, right? So say for example we have a variable named a, so a is equals 5, and then we are printing this value from here. So alright, so within this function we have a variable and we are printing this variable. So let's see, let's run it. Okay, we are printing this 5. Nice. But the thing is, in Java you couldn't access this variable outside the scope, right? Because the variable would destroy after this, whenever this scope ends. But in Bash you can always access whatever within any function. You can access the variable within any function. So you can just print it. So let's see. So we are accessing this variable which was within this function outside of this function. So it's no longer working. And say we had previously declared some value which was replaced within this function, and so as you can see it's still printing 5. So it doesn't really matter if the variable sits inside or outside a function, it will be treated as same. Now if you want to specifically declare a local variable for your function, you have to use this local keyword. So if you use this local keyword, then Bash will treat this variable as a local variable, and it will not affect the variable sitting outside this function. So if I run it, so as you can see now, when we were executing this hello world function, we were executing this within this scope. So this a was basically this a, which is 5, and when we were outside of this function, and this a is basically this global a, which is 7, so it's printing 7. So this is how you declare local variables for your function. Now let's see how to pass parameters to a function. So for that we are going to create a function called adder, which will add 2 integers. So this is our function. Now in our traditional programming languages, we could pass the parameters like this, right? A and b, and then we could add a, b. However, we cannot do this in Bash. We have to use similar approach like the one we used in our command line arguments, where we access the command line parameters using the $, and then 1, 2, 3, 4, the corresponding number. So here we are going to use the same. So what we are going to do is we are going to print the value of, since we are going to use an arithmetic operation, we need double bracket, and we're going to add 2 values, right? So the first parameter and the second parameter. So the $1 indicates the first parameter and the $2 indicates the second parameter, and then we just call it and pass the parameters. So say we're trying to add 3 and 4. So the name of the function, and then space. Similar to the arguments, we are passing the parameters like this using the spaces. So space 3 is the first parameter which we are accessing using this $1, and for the next parameter we're accessing it using the $2. So let's run it, let's see what happens. So as you can see, it's adding these 2 numbers. So 3 plus 4 is 7. So again, so let's 5 it. So if it's 5, we can see it's 5 plus 4 is 9. So this is how you pass parameters to a function in Bash. Now let's see how to return a value from a function. Okay, so let's first store it in a variable called result equals and this. So first we are storing this variable and then we are going to return it. So for a return we are going to use this keyword called return. So return, and then so we are returning this value of result, so return result. Okay, and similarly we are executing this function with these two parameters 5 and 4, and now we are going to access this value that has been returned from this function. Now it works a bit differently than traditional programming languages, where you could just store the return value in any variable, but in Bash it's specifically stored in this question mark variable. Okay, so whenever a function is returning something, it will always be stored in this question mark variable. So to access it, all you have to do is say, let's just print this, so echo then this $sign question mark. So we are printing the value of this question mark variable. Okay, now let's see what happens if I run it. Okay, see, it's printing 9. Now if you have multiple functions running, then if each function returns a variable, this question mark variable will always overwrite with the latest function that has been called. So you have to keep in mind that you cannot store this cannot store the return variable from the function to any variable you want. It will be automatically stored in this question mark variable. Okay, and then you can just access it using the $sign question mark. So now if you want to store this question mark the value from the question mark to other variables, then you can do that, but by default it will be stored in this question mark variable. Okay, so thank you so much. This is all for this lab, so best of luck.